Hi class, hope y'all have been doing well. For this exam, Unit 3 exam, you will have it tomorrow on Wednesday. This one you will only have one day to take it though. It is a shorter exam and an easier exam. This will be your first summative grade for quarter 2 grades. So again, if you have Unit 3 as a higher exam as compared to Unit 4, I'll keep the higher grade in the grade book just to help you out. I should be back by Unit 4 exam, to be honest, but I'll be back in a couple of weeks, so I'll see you soon. So let's start review with Unit 3. So circle the correct answer that makes the sentence true. So enzymes benefit organisms by speeding up or slowing down reactions. Here, our keyword is enzymes. You can always, on your scratch sheet of paper on the side, just do a little, oh my gosh, brain dump, sorry. So enzymes are proteins, remember? That is one of our 4 biomolecules that we learned. And enzymes speed up or catalyze reactions. That is their main function. So speeding up reactions, making them go faster. So enzymes are commonly known to be in our digestive system to speed up digestion and other processes in our body. Photosynthesis uses or releases oxygen, uses or releases carbon dioxide. So they like to use this type of vocabulary. To use something means it is a reactant. And to release something means you produced it, so it is a product. If you remember from previous notes that you should have, it is a reactant plus a reactant will equal or will yield a product. So photosynthesis, does it oxygen go in or out, right? So we know that in photosynthesis, we love this process because it releases. It creates oxygen for us to breathe in. And it uses or releases carbon dioxide. It is going to use carbon dioxide. So for this one, just some quick justification. Remember photosynthesis, you have light plus water plus carbon dioxide. Those are your reactants to yield or produce glucose and oxygen. So there we have it, guys. Cellular respiration. So remember, cellular respiration is how we convert our food into energy. Cellular respiration is going to be the opposite. It is the reverse reaction. So we know that in cellular respiration, our food is made up of sugar and glucose. So we have glucose and oxygen, which are our reactants, and they produce water, carbon dioxide, and they do not use light energy. The type of energy that they produce is ATP. And that's very important because ATP is cellular energy. A very good practice for you to have for Unit 3 exam is as soon as you get your scratch sheet of paper, write your formulas for photosynthesis and cellular respiration. Study them. If you haven't perfected them, I would highly advise for y'all to study it for tonight. And then you can write it in on your paper tomorrow and it'll help you through the process. So in cellular respiration, we see that oxygen is on the reactant side. So it's going to use oxygen and it's going to release carbon dioxide. It is a byproduct. Circle the 2 reactants that glucose is produced from. So again, here we see these words. Produced is the product. And what process has glucose as a product, right? So where is glucose produced? We know that that is photosynthesis. So again, photosynthesis is light and water. Just think of how you would grow a plant, right? They need light, water, and carbon dioxide to produce glucose, which is the food for the plants, and oxygen, which is the gas for us. Glucose is C6H12O6. So what 2 reactants? Looking here, we know that ATP is specific to cellular respiration. Here on our reactant side, we have water and carbon dioxide. Right next to glucose, you can see oxygen. Oxygen is also a product with it for the process of photosynthesis. So that's just something to remember. Whenever you see glucose, think of oxygen as well because they're both the products of photosynthesis. For this one, very visual. So the star has shifted to a lot of visual representations and graphs. So you will be seeing that a lot on your unit exam. They're going to give you tables, graphs, images for you to look at and identify what they labeled. So again, here we have our enzyme substrate complex. If y'all remember when we played with the pool noodles, and we were using those as examples for enzymes and our substrate and our enzyme substrate working and all of that. That's what this is. So looking at the image, here we have Y. So Y is representing this on the bottom. X is representing what connects to it, the little puzzle piece. And Z is at the very end, so that should give you a clue about what that is. You can try to answer it on your own, but once you're ready for the review part of it, so Y, remember, if you look at Y, it is exactly the same throughout phase 1, 2, and 3. So Y is your enzyme. It is important to remember that enzymes remain unchanged. The piece connecting to it, so the Y is our lock, like in the lock and key model. The piece connecting to it, that would be considered your substrate. And then lastly, at the end, your substrate will change. It is going to break into little pieces. Those are your products. So again, in phases 1, 2, and 3, in phase 1, what's happening is you have your substrate, and enzyme. So here, basically, this reaction is off. Just like a lock and key model, you have your key, it's near the lock to your house, but you haven't put the key in yet. They're not connected, it's not open, so nothing is happening, but you have the pieces there ready to go. In 2, what you see there is your substrate enzyme complex, or enzyme substrate complex. So here, your reaction is actually on. Once they are clicked together, they fit perfectly, lock and key model, your key is in the lock and you're turning it. That is a functional reaction. So in phase 2, once they're connected perfectly, that is a functional reaction. And then lastly, 3, products are created. And then once you're done there, your enzyme turns off. There's nothing connected to it. If you look here, your enzyme is off, nothing's connected to it. It's not broken, it's just waiting for a substrate to come again and then restart the process. So looking at this one is interesting. Just looking at the organelle, I like to remind my students, like, it kind of looks like an M. So when you see that little image, you should automatically be able to remember that this is your mitochondria. Remember, your mitochondria is the powerhouse of the cell. That's what it's known for, where energy is produced for cellular processes, where the energy is for your body. So that should help you remember ATP. So what organelle is shown? Looking there. Again, if you look at these little curves inside, they should kind of look like an M. So that should help us remember it's the mitochondria. What process occurs in this organelle? So for this specific organelle, it is cellular respiration. So anaerobic, aerobic, anything like that, they'll probably can't throw those words in there, but just know that it is respiration. It is the way that you turn your food or sugar into energy. All eukaryotic cells have to go through the process of cellular respiration. The one cell that is really special is going to be your plant cell. Your plant cell has chloroplast. That's where photosynthesis happens. So they go through the process of photosynthesis, but they also have a mitochondria because they're a eukaryotic cell. So cellular respiration happens there. Very important to remember. Animal cells. We fall under the animal category, right? Animal cells do not go through photosynthesis. They only go through cellular respiration. We cannot sit out in the sun and gain all this energy, right? We have to eat food, and then by eating our food, then we go through cellular respiration and create our energy for our bodies. So all those hot Cheetos and Takis and all of that, you do get energy out of it at the end of the day. So what product is missing and depicted? So the way that you can tell from this image that it is a product is arrows going in are your reactant and arrows going out are your products, right? So again, we said that the process that occurs in this specific organelle is cellular respiration. So if you remember, cellular respiration is the opposite of photosynthesis. So you create ATP, water, and carbon dioxide. Oh, I did that completely wrong. Sorry. So for cellular respiration, it's going to be the opposite or the reverse reaction. So you have glucose and oxygen that produce or create. So your product is energy, ATP, water, and carbon dioxide. So again, glucose is a sugar. So the sugar in our food gets broken down to produce that energy. So we already see water. We already see carbon dioxide. Which one is missing? Here we are missing ATP. That is our main goal from this process. So looking at the graph, again, we're going towards a more visual exam these past couple of years. Looking at the graph describes the relationship between enzyme activity and temperature. So here we see increasing enzyme activity and increasing temperature. So it's just common knowledge that right there would be 0 and we can say like 100 over here. So enzyme activity right here is increasing. So as temperature increases, your enzyme activity will increase and then you reach your optimum. So this is our optimum area. It's working at its best, and then after a while, it just starts to decrease. So when you're looking at where your enzyme works best, it would be at this specific temperature. We don't have a reading for it, but it would be that temperature. So again, enzymes are proteins. So proteins work at a certain temperature. Depending on the protein, there's going to be a temperature for it where it's working at its best. But proteins go through something that is called denaturization, or they denature. Basically what happens is the proteins get undone and they no longer work. So that's what you see happening here. They get to their best work, and then at a certain temperature right here, it is getting too hot. So those enzymes stop working. True or false? Increasing light intensity. So remember, increasing means up. That was a bit much. Increasing light intensity increases the rate of photosynthesis. So again, we see photosynthesis. I know we have light plus carbon dioxide plus water to give you oxygen and glucose. It's just a force of habit. Whenever you see photosynthesis or cellular respiration, always go back to your reaction. Some way it's going to help you. So again, having more light is going to increase the rate of photosynthesis. If you were able to do your gizmo on the photosynthesis, you're going to see that this is true. If you have a plant in a dark closet compared to a plant by the windowsill, the one by the windowsill is going to grow more, or it's going to produce more bubbles because it is going through the process of photosynthesis. So having more light will increase the rate. Obviously, it can happen. It gets too much light, it dies or it dries out. But for test purposes, increasing light does increase the rate of photosynthesis. At what temperature does photosynthesis work at its optimum? So remember, optimum, el óptimo, it's basically like where is it working at its best? So looking at the image, we have the rate of photosynthesis, the temperature, and its photosynthesis versus temperature. Here, you have your number down there, the peak. This is your best work. So by looking at this graph, you can say photosynthesis works at its optimum at 25 degrees Celsius. Again, and I see that there. You can see that on the graph. You can restate the question to help you write your answer. There's nothing wrong with that in science. I want to say the rumor was that it was AI graded, so they're looking for specific structure. Your best bet would be to stick to the way that you restate the question and just simply give the answer. When I get back, we'll definitely go over open-ended a lot more, but please try to answer that open-ended. As I'm grading your exams, I get a lot of no sé miss, I really forgot, I'm sorry, how are you doing? While I appreciate it, please try your best to provide some sort of quality answer because you can get partial credit. So the question is worth 4 points and you have one specific word in there, you might be able to gain 1 point and that might get you to passing. So again, échenle ganas, papitas. True or false, cellular respiration increases temperature. So cellular respiration does increase temperature. This is a process where you're creating gases like carbon dioxide, and just think of like energy. Energy is heat. True or false, cellular respiration is a process that converts light into chemical energy. So we know that this is false. The process that goes from light to chemical, that is photosynthesis. Sorry, the boys are already getting loud. I'm outnumbered. I will post this. I'll clear it up and make it a lot better. It'll be posted in Teams. Again, please go to your Teams. Everything is there. If you haven't used it, sorry for all the apps, guys. So when you go into Teams, the team that you need to look at is the 9th grade team that I created. So 24, 25, 9th grade. Go under bio. And then under bio, you will see everything is posted there. So I post your exemplars. I've been posting your grades. I tag y'all. There's videos. Anything that you need will be there. So again, go into that team. From what I understand, your long-term sub is already there. So that's exciting. You'll have some consistency until I get back and I'll get in contact with them. But all the notes are there. So if you're wondering where you can access it, everything's been posted there. I also posted a notebook. So yours is at the very top. You can go into Unit 3. You're at Unit 3. You're going to end with Unit 4. And then next semester we'll go. But if you go into this one, our apps, Unit 3 lesson, everything will be there. So I post it by day. You'll be able to see your review. So like enzyme structure and function, if that's something that you wanted to review. When you go there, there's videos, there's the PowerPoint, there's notes. Let's say that you wanted to review photosynthesis. It is right there. So again, we're almost done. You will test on Wednesday, and then starting Thursday and Friday, Unit 4 gets into body systems. So that one's exciting. You can connect to that one because you go through it. Best of luck on Unit 3 exam, guys. If you have any questions, feel free to message me on Teams, and I'll help you with whatever I can. And I'll see you in a few weeks. Bye, guys.